This week on Waterways, Cape Sable Erosion and NOAA dive training.
For some reason, it's in people's souls that want to wake up in the morning and hear the surf. I don't know why, but you can see it all over the world. Where people can afford to live on the water, they will.
While most Sunbelt real estate markets are hot, South Florida is among the hottest. In South Florida, housing prices are rising by more than 20% per year. Tens of thousands of people close to retirement are buying property. And the kind of property they desire most is a home on the water. But while the real estate market makes its climb, another force is also rising, slowly, relentlessly: the sea. Since 1930, the level of the world's oceans has risen by 10 inches. Most coastal residents have yet to feel the change. But at the extreme southwest tip of Florida, the changes can be felt and seen.
Our sea level rise is very real. The tide gauge records have been recording it very carefully and accurately. And the 10 inches of sea level rise we've had in the last 30 years that's a rate of a foot per century. That's close to a catastrophic level for a coastal system. It does put all coastal systems into change.
Cape Sable is a half-moon-shaped peninsula of land and water within the boundary of Everglades National Park. The Cape covers 150 square miles and is a miniature version of the rest of South Florida. It features Florida's most remote beaches. It contains hardwood hammocks, mangrove creeks, salt marshes, and barren prairies. It is also very low, lower than much of South Florida. It is here at Cape Sable that University of Miami geologist Hal Wanless and his doctoral student Brigitte Vlaswinkel have set up their laboratory. Funded by the National Park Service, they are chronicling the sea's push landward. They know that what happens here will eventually happen in the rest of South Florida. The first barrier that the rising sea has to face is the beach. To most people, beaches are wonderful places to walk and explore. To a geologist, a beach is a ridge of high land that separates the ocean from areas inland. At Cape Sable, dredges gave the sea a helping hand. In the 1920s, before the establishment of Everglades National Park, dredge workers cut 2 small canals through the beach ridge. These canals saved nature a few decades of work.
This small area is changing so rapidly because small modifications were made to the system, and these small modifications act as a catalyst. Basically, they speed up the processes. And this is interesting because we can study it faster and we can see what might happen to other areas along the southwest coast of Florida and other very low-lying coastal areas that are being affected by sea level rise and more storm events. But in this study area, we can see everything happening a lot faster.
The small canals or modifications that Brigitte mentions were less than 18 feet wide in the 1920s. Locals joked that you could jump across them. Today, they are more than 200 feet across. Every day, they allow the sea to tear into the Cape's interior. The canals are also the cause of a geologic twist of fate that the dredgemen did not anticipate. Under normal conditions, sand is constantly carried away from the beaches at the Cape. The reason the beaches don't disappear is because the sea also carries fresh sand from the north to replenish them. However, the Middle Cape Canal has become a tidal river that keeps beach sand from traveling south. Starved of sand, the beaches south of the canal are being eaten by the sea, and these beaches may soon be gone.
So we have lost over 1,000 feet of the width of the coastline between the Gulf of Mexico and Lake Ingram in the last 70 years. And probably within another 10 years, this coastline along here will disappear because it's very narrow now. There are numerous little inlets just waiting to open up. This whole coastline along here is actually like icing of sand on top of the underlying sequence, which is about 2 meters of mud, of marl and organic matter. And so as this channel widens and erodes, as this shore erodes, it doesn't provide more sand to be recycled.
Once inside the beach ridge, the sea begins to rearrange the landscape. Twice daily, the tides push a slug of water into the cape's interior and draw it out again. Brigitte Vlaswinkel, a native of the Netherlands, is tracking the changes. Her work often requires clever inventions.
So I used a very simplistic approach to looking at how much sediment is depositing in the lagoon. I took carpet tiles and I put them on the sediment in the lagoon. And over time, sediment is being, of course, accumulated on these sediment traps. And I put 4 at one position, and I go back after 1 month, 2 months, 4 months, etc. And I'm looking at the rate of sedimentation, basically.
Most geologists study events that happened long ago. Brigitte is studying geology in action. She is watching land dissolve and form in real time.
Over the last 2 years, I have done a couple of weeks of experiments that I was here almost every day, measuring the process dynamics. And with that I mean the waves, the tides, how much sediment is in suspension. For the sediment traps, I go out once a month and I collect them.
Brigitte's work has revealed that these canals are acting like giant conveyor belts. They pull mud and peat from the wetlands behind Lake Ingram and carry it to Florida Bay. While some of the mud will stay in Florida Bay, canals will carry much of it back into the canal and to Lake Ingram, where it is forming a delta at the lake's southeastern end. The canals also eliminated the freshwater and brackish wetlands that used to occupy the Cape's interior. Before the canals, Lake Ingram and the Cape Sable interior were fed by rain and safe behind the coastal ridge. Today, they are connected to the sea and have become marine lakes and salt ponds.
Now this inlet, which is in ebb tide phase now, is feeds water into Lake Ingram and out of now. Lake Ingram used to be an isolated body of water that had storm tides and stuff might throw a little salt in it, but it was basically a fresh to brackish water environment. And this is one of our fascinating situations that we have in South Florida, because we're trying to learn how to manage our environment in times of global warming, in times of rising sea level.
Fortunately, there is no development here. There aren't any residents watching their lots disappear. There are no towns losing their freshwater ponds and sources of potable water to the sea. But there are changes for the animals that make Cape Sable and Lake Ingram their home.
The lagoon is silting up quite rapidly, and it's providing a lot of nice habitat for new birds coming in, such as white pelicans, and also the fish population is changing. More saltwater fish is intruding into the former freshwater areas, basically. So again, some birds are disappearing, but on the other hand, because of the ecosystem changes, other animals come in and benefit from the new situation.
While the changes that Dr. Wanlis and Brigitte are studying might seem fast, they acknowledge that things could change even faster. Perhaps even in the course of one season, if the Cape is visited by a hurricane. Cape Sable has been spared a direct hit since Hurricane Donna in 1960. In the summer and fall of 2004, any one of the 4 hurricanes that hit Florida could have made a minor change in direction and hit the Cape. History tells us that it is only a matter of time before the Cape suffers a direct hit. And when it does, Cape Sable, as we know it, may be history. A hurricane can send a wall of water 15 feet high over the land. A direct hit by a hurricane would most likely tear away the sliver of beach ridge that separates Lake Ingram from the sea. A direct hit would kill hundreds of acres of mangroves and leave the mud beneath them open to erosion. It would widen the canals. In short, a direct hit could take a measurable chunk of Cape Sable with it. The National Park Service is studying the Cape and considering what it can do to keep it natural as long as possible. Should the canals remain open? Should some canals be filled in? Is saltwater intrusion killing the inland marshes? Would plugging canals do more harm than good to the marshes? While Brigitte and Hal's findings will help the park, they could also be a wake-up call for the rest of South Florida.
Our isolated little Cape Sable sitting down there by itself is actually its own little world. It has all the elements of the environment that we see elsewhere in Florida. Beaches, mangrove swamps, mud coastlines, freshwater interior, saltwater marshes, and so on the edge. And to understand how these work without the confusion of other influences such as changing the freshwater drainage and so on of the Everglades helps us to better understand how each part of the system is responding to sea level rise and other aspects of global warming, how it's responding to hurricanes.
It may take homes washing into the sea for most people to wake up to the problems of rising ocean levels and beach erosion. Fortunately, some scientists and resource managers with foresight are studying these impacts on Cape Sable. While Wanless admits there is not much that can be done to curtail rising sea levels, his work with Vlaswinkel will definitely provide the research from which we can learn to adapt to these new conditions. For most American workers, getting to their place of business is as simple as driving their car, boarding a bus, or taking the subway. But for several hundred employees of the National Oceanic and Atmospheric Administration, getting to the job site means donning dive gear and journeying underwater. Whether 10 feet or over 100, their dive skills are a means to their mission to observe, monitor, and collect information to protect both the environment and the humans that depend on it. NOAA divers work throughout the oceans and inland waters of the world, in conditions varying from the crystal clear water of the pristine marine sanctuary to the murky and polluted water of a congested harbor. On any given day, NOAA divers may be seen deploying and retrieving scientific instruments, documenting the behavior of fish and other marine animals, performing emergency and routine ship repair and maintenance, assessing the impact of man on the environment, and locating and charting submerged objects.
NOAA is the premier ocean science agency for the United States, and you can't have an ocean agency without having divers, to be honest. There are tasks that have to be done underwater. There's absolutely no other way to do them.
With more than 400 divers, NOAA has the largest complement of divers of any civilian federal agency. Averaging more than 15,000 dives per year, many under challenging conditions, the NOAA diving program has consistently maintained an excellent diving safety record of nearly 99.97% safe dives, meaning that incidents are reported on only 3 out of every 1,000 dives. Contributing to this excellent record is a NOAA dive program that provides standard, well-maintained equipment to every diver, a requirement that divers practice their skills throughout the year, and a challenging 3-week training program.
The NOAA 3-week working diver class is a very rigorous physically and mentally class. It's designed to take a non-diver and in 3 weeks make them somewhat comfortable.
Well, some of our divers are scientists, some of our divers are officers that work off of our ships. Diving for NOAA is a collateral duty, so it's not their main purpose, but diving just helps them accomplish their task. The scientists obviously counting the fishes, looking at the corals, the ship divers for working up underneath ships and unfouling props if they become foul.
Once a year, NOAA's elite diver training program moves from its home in the chilly water of Seattle, Washington, to the warmer weather of the Florida Keys, where the Florida Keys Community College maintains a state-of-the-art dive training facility for its own diving programs. An army of black-clad divers descend on the campus for what has been called a diving boot camp.
Of course, the NOAA Diving Center is where we conduct majority of our classes, which is in Seattle, Washington, at the NOAA Western Regional Center. And we have a fabulous facility out there. And a number of years ago, it was determined that it's just too darn cold to conduct this class in Seattle in January. And we conduct this class in January, May, and September. So we were advised to find a warmer climate. So about 5 years ago, I had read an article about this fine facility at Florida Keys Community College. I came down and met the director, Bob Smith. He showed me around, and I was very impressed with the facility. It comes as close to the NOAA Diving Center as anything else we've seen.
While most of the trainees work for NOAA Dive Center's reputation as a leader in diving and safety training has led to frequent requests from other governmental agencies to participate in NOAA diver training courses.
We trained the U.S. Secret Service divers. We've trained some FBI agents. Almost all of the federal science agencies, the EPA, USGS, U.S. Fish and Wildlife. We trained quite a few of the state agencies, Alaska Department of Fish and Game and Washington. And then we could fill every class if we wanted with safety divers, search and rescue, fire departments, and this kind of thing that want to come to our class on a spaceable, available basis. Basically because they can't find this training anywhere else.
Depending on the class, some of the working diver trainees may have no experience at all with scuba, while others have thousands of dives. For the new divers, the course can be a series of challenges as they begin by getting used to the unfamiliar equipment and learning basic scuba skills. The training quickly progresses through a series of 28 dives. The trainees are trained on a deep dive and a night dive. To help them learn to recognize the effects of nitrogen narcosis, a condition that can degrade divers' judgment at deeper depths, the students simulate a dive to 130 feet in a recompression chamber. The students learn to work in dry suits, used for cold water and in polluted water diving. They learn to use AGA masks, which cover the whole face and are also used for protection in polluted water, as well as when underwater communications are needed. Up until this point, much of the class may be a review for more experienced divers, who find themselves focusing on how to break bad habits. Upon graduation, the new working divers get a certification card from NOAA, along with a NOAA Master Diver card, a widely recognized recreational diving certification. So how will these newly minted NOAA working divers use their skills? NOAA working diver Wayne Lusardi will return to the chilly waters of Thunder Bay National Marine Sanctuary to help share the history of the submerged shipwrecks of the Great Lakes.
Thunder Bay National Marine Sanctuary and Underwater Preserve was designated in 2000 to protect an historically important collection of shipwrecks. There are nearly 200 shipwrecks in and around Thunder Bay in Lake Huron in northeastern Michigan. And I'm the archaeologist there, and I'm responsible for documenting, researching, and learning about these very important cultural resources, and then sharing that information with the academic and public communities. The most efficient way of understanding these wrecks is by putting divers down on the bottom so that we can record them, document them, draw and measure all the pieces and parts, photograph, and do whatever research is required to understand these wrecks fully.
Meanwhile, Noel Cartman, a diver with the Florida Keys National Marine Sanctuary, will use his certification to install and maintain mooring buoys, which allow vessels to tie up, rather than dropping anchors on the fragile coral reef.
When we install a mooring buoy, we have several different systems depending on the substructure of the bottom. In hard bottoms, we have to physically jackhammer into the bottom, creating a hole to actually creates two holes that we can cement in a stainless steel U-shaped anchoring device with epoxy.
Noel's colleague, Wayne Nuisen, will use his certification to help make sure the vessels of the Florida Keys National Marine Sanctuary remain in good working order, ready for use by the sanctuary scientists, educators, and law enforcement officers in their work to protect the coral reef ecosystem.
And the reason why I'm in this dive class is because when it comes to maintenance, it is a good idea to not just look at what's on the top side, but also to look what's going on with your underwater body and your hulls. And that helps me to keep the boats running and helps the biologists and all the other people that need the boats to get their mission done.
During the third week of the working diver class, we bring our dive master candidates in. Now, the dive master candidates are NOAA divers that have been through the 3-week class and have been in the field for at least a year, and now they're coming back to learn diver leadership. We challenge them in several ways. Most notably, we impose problems during the dives that they have to solve.
Each dive master also responds to a simulated emergency. Classroom instruction focuses on recognizing potential problems before they occur, and counseling divers on how to react if they do. Over the years, NOAA has established itself as a leader in the diving industry. The agency publishes a comprehensive diving manual that is one of the Bibles of the field. And as NOAA safely pushes the envelope in dive technology, more challenges lie ahead for the NOAA diving program.
We're seeing more and more remote diving activities happening in NOAA. For instance, the Northwest Hawaiian Islands is a new hotbed of diving activity, and that imposes some problems for us, and that mostly is the remoteness of the diving. And we're very concerned about the safety of our program, and when you have divers diving very intensive diving, 3 dives a day for several weeks at a time, we are very concerned about their safety. And as a result of that, we are developing hyperbaric chamber units that are containerized to go on these NOAA ships.
Training and technology are not a goal in themselves, but a way to help these guardians of the seas accomplish their mission. While these divers may be considered adventurous, to them, it's just another day at the office.